Hi, welcome to the session on MergeSort. So MergeSort actually works on the technique of divide and conquer. So what exactly the divide and conquer we already discussed in the session of divide and conquer. We will going to, if there is a list of element, we're going to divide, okay, so that into some smaller component, and then after that we'll try to find sort this particular the list of element in either in the ascending or descending order. Now why exactly do you think the divide and conquers actually helps? Like, because if we have a large set of numbers and we really want to sort that numbers, it becomes very difficult. The complexity becomes high. So what exactly we are doing? We are divided into smaller, small parts, right? So it becomes easy for us in order to do whatever operation you want to do smaller. And once we done, then again we will going to combine these two, and at the end we got. That is how exactly MergeSort will be working. So if we have an array of elements or a list of elements, okay, so we will divide into two parts, okay. Then what exactly we're going to do, we'll take the rest of the two part and we'll further divide it, okay, so that we get the smallest unit, right? And after that we take the two smallest unit, we try to compare, then we try to merge it, and we'll try to come up, and as a whole the entire list of elements will be gone. Yes, okay. And see, here it is saying we are dividing into two sub-arrays, and that two particular sub-arrays again will be divided into sub-arrays. So the sub-arrays will be sorted independently and then using recursion. Okay, so I hope you remember recursion means a function which call itself, right? So each time we will going to use this concept of recursion, okay, and then to get the smallest the sub-arrays, and then we'll sort it, and then we'll start merging. So sorted sub-arrays are then merged and get the solution of the original array. Okay, so I hope till here you should understand that MergeSort divide on the follow the principle of divide and conquer. What mean divide and conquer? We are dividing the entire suppose a list of element into sub list, or if you say arrays, sub array of equal size, and then this sub arrays we independently will try to sort it, and the concept that we're going to use is the recursion sort. And after the sorted array, what we do is that we're going to merge it, and we'll continue to merge, and we'll get the entire the original array or the list itself. Okay, so now this is how the algorithm works. So if this is a list, okay, see if it is it's an array, so start from 1 to n. So we take 1 as the left, okay, right as the n, okay. And then what we do is that if left, this is left, is less than right, yes, 1 is less than right, okay, so we take m equal to floor left plus right, so we add this to 1 plus n divide by 2. Okay, yes, and whatever value we'll get, okay, floor means the smallest, the lower values, sill means you take the upper value, right? 3.2 will take 3, okay, like that. Okay, so then what we're going to do is that once it is m is then we take it from left to m, okay, from 1 to that position of m, okay, and from m to n, and sorry, m plus 1, because you already taken till m, so m plus 1 till right. Okay, and then again we go back, and we can for this particular array again we will see if whether left is less than right. Okay, if not, then again we will set this m left plus right divided by 2. Okay, and then again we make that array itself from left to m, 1 plus m to right, and this way we continue. Okay, whenever left is equal to right, we stop. Okay, and once we stop, we started merging. So from the left to m, okay, and from m plus 1 to right, okay, into an auxiliary array b. So we'll not going to merge it in the same array. Okay, we'll take another array and then we'll merge it. Okay, and at the last we'll copy the element from b to a. So if you see this particular algorithm itself, one particular point or thing comes into mind. Okay, that means if I have an array of 1 to n, okay, I am considering another array of b also from 1 to n. Yes, it's correct. So that's what is called the auxiliary array, and that is one of the disadvantages of MergeSort also, right? See, because whatever size of array is given, you have to clear the auxiliary of the same size. Okay, right? But while handling, we'll see in the end, while handling larger amount of data also on the disk, data during the disk, this MergeSort plays a very important role. Okay, so anyway, I hope you've understood the MergeSort concept itself. So I take left equal to 1, right equal to 1. Okay, then I divide the array into two sub array. Then I take the sub array, again I divide it further into two sub array of the left, also for the right, and we continue to do the right. Once it is done into smallest unit, okay, we start merging. Okay, and we come, and once we start merging, we copy the element from the B to once the complete merging has been done. Okay, sorry, once the merging is done, we'll store into the array B. Okay, so this way we'll have the array which B will in the on the sorted form, and then after that we copy the elements of B to A, and then A becomes nothing but in the sorted order. Okay, so let us see. So same set of element I have taken 30, 45, 2, 16, 31, 7 and 23. Okay, so now left is, what is left? Right is, tell me what is the value of left? Is 1. What is the value of right? 7. So 1 plus 7, it is 8. 8 divided by 2, it is 4. So I got it 4. Okay, so this is my left sub array and this is my right sub array. Okay, now I got this left sub array 1, 2, 3, 4. Now I will again divide it into 2, because now you see 1 plus 4 is 5. 5 divided by 2 is 2.5, and I take the floor value, that is nothing but the 2. So 1, 2, and then 3, 4. Again I take this array, again I divide. Okay, so it will be divided into 30 and 45. See, it will be divided into 30 and 45. Okay, similarly 2 and 16, this will be again divided into 2 and 16. Correct? Yes, so this is my left sub array. Okay, this is my left sub array, this is my left right sub array. Okay, so here again I'm saying 1 is left, 7 is right. 1 plus 7 is 8. 8 divided by 2 is 4. So 4. So this is my left side, this is my right. Now I take the left side. 1 plus 4 is equal to 5. 5 divided by 2 is 2. So I get this 2 element. I get this 2 element. Again I further divide this. 1 plus 2 divided by 3 is 1. So 1 and 1. Okay. So I have this sub array. Okay. And here I have this particular sub array. I have this 30. Then I have this 40. Left sub array. Then you have 2 and 16. Okay. Yes. Right. Now I take the the auxiliary array itself. Okay, yes. Now if you see here one particular thing, okay, let me see. Okay, now I take this particular left sub array and the left right sub array. Okay, so I have this 30, 45, 2, 16. Okay, so I start comparing 2 and 30 and 2. I have is 2. Okay, then 30 and 16 I will compare. I will have 16. Okay, right, then I copy all the remaining name from the left sub array to the auxiliary. So I copy this 30, I copy this 45. Okay, so let me again go back so that the things get clear. See here, once I break down into 30 and 40, 45, so which one is lesser? 30. Okay, so I have 30 and I have 45. Here lesser is 2 and I have 16. Otherwise, you see, again we do a comparison, and then so this is one sub array that I have created, and this is one right sub array. Right now I take this 2 array, okay, and then I started comparing. So I will, what the concept of comparing and putting is that I take this one particular sub array, right, so this left sub array, this is right sub array. So I compare 30 and 2. So 2 is the smallest, so I put 2. Then 30 and 16 is code, but this array has been completed. So whatever the remaining left array is copied. For example, 2 and 16 was here, 2 and 16 were here, 30 and 45. So I could have got 2 and 16 here. Then rest of the file from here I have to copy it this. So now after I've been doing this, so 2, then 16, okay, and then we got copying the remaining element 30 and 45. Yes, so that is what we got for the left sub array. Okay, similarly, okay, okay, right, similarly I copied it back. Okay, yes, sorry, I copied it back to my left sub array. Okay, right? So left sub array sorted successfully. Okay, then I will go for the right left, sorry, this is for the right sub array I will go. Okay, so right sub array again we'll have 31 and 7. Okay, so right left sub array, and this is the right sub array. Okay, so similarly here also I will do the sorting. Okay, so I get 7 and 31, and then here 7 and 31. Okay, then I will try to compare this, okay, with an auxiliary array. So I said 7. Okay, 7 is less than 23. Yes. Okay, done. 31 is less than 23. No. 21. So what is remain? It is remain already right has been done. So only right left subarray remains. So whatever elements is written, we put it down. So we have 31. Now the right subarray we have 7, 23 and 31. Okay, now what I have to do, I have to take this left subarray and right subarray, and then I have to do the sorting. Okay, so now 2 less than 7, yes, so I got 2. 16 less than 7, no, so I will put 7 now. Then 23, 16 less than 23, yes, I got 16. Then 30 less than 23, okay, no, 23. Okay, 30 less than 31, no, we have 30. Then 45 less than 31, it is no, so we have 31. Okay, then we have 45, the remaining element is there. So let me again go back. I may have 30, 60, 16 is less than 23, yes, so I put it here. Okay, now 30 is less than 23, no, so I put 23. Okay, 30 less than 31, yes, again I put it in the array. Okay, then I have 45 less than 31, no, so 35 and 45. So we got the elements all in sorted, right? So MergeSort, actually typically it happens that you're going to sort the elements based on the concept of divide and conquer. So I hope you have understood the MergeSort itself. Okay, so now we have to copy the auxiliary array to the array A. Okay, so we do the copying. So 7, 16, 23, 30, 31, okay, and 45. Okay, so now we got all the elements, the original array we got in a sorted form, and you have seen that we have used the auxiliary array itself. Okay, right? Now the thing is that since you have seen, if you are using array, okay, here which requires it requires a small constant amount of auxiliary array, so usually preferred over the linked list. Okay, and it is used to store use data storage in the external devices such as a hard drive, as it minimizes the expenses reach of the external hard devices. Okay, so I hope you have understood MergeSort. So do please keep watching my video. Thank you so much. Do subscribe and please share with your friends. Thank you so much.